Okay, so if we go to our website and we click on projectile motion, follow that link, you'll see a few files here. This is where I'm going to put all the screencasts to help you with your problems. If I download projectile motion practice right here, and I go ahead and open it up, let's see what I have here. So we're talking about problems 1 through 4. We'll start with those. Okay. And let's see, we have an object thrown horizontally off an 80-meter cliff with a horizontal velocity of 10 meters per second. Okay, so let's see what we can figure out. 80-meter cliff, and what was the other thing? 80-meter cliff, initial horizontal velocity of 10 meters per second. Okay, so let's see. I can draw my cliff. And this is supposed to be 80 meters tall. So this is 80 meters. And my projectile goes off horizontally with an initial velocity in the x direction. And then it hits the ground some distance away from the cliff. All right, so let's see what we can figure out. And the speed was, what was it, 10 meters per second? Let me double check that. Yeah, initial horizontal velocity of 10 meters per second. Okay, cool. So this is 10 meters per second. All right, so horizontal motion is going to be basically constant velocity motion. I'm just going to start with a velocity in the x direction times time. And I'm going to draw this as a horizontal line because my horizontal velocity isn't going to change. And I know the value is 10. I don't know the time to hit the ground, so I'm going to call that t. And then this area I don't know either, so I'm going to leave that alone. Let's see what the vertical motion can teach me. Vertical motion. Let's see. I'm going to draw a velocity graph again. Only now, my velocity in the y direction is going to start as nothing, but then as time goes on, my projectile is actually going quite fast downward as well as horizontally. So it's the same thing as if I dropped an object from rest. Since the velocity in the beginning is horizontal, the beginning velocity in the y direction is going to be 0. This is v initial in the y direction is actually 0 meters per second. So I dropped the object from rest and the graph would look like this. And this area would be the height of the cliff, which I happen to know. So I don't know the time t, call that t. I don't know the final velocity, but I know this area is 80 meters. But I do know if I draw an acceleration time graph, that can give me my my change in velocity. So why don't I go ahead and draw that? And this is saying that down is positive in direction because my acceleration is positive. So if I say my acceleration is 10 meters per second squared, so my velocity was meters per second, my time's in seconds, my acceleration is meters per second, and time here is in seconds. Again, I don't know my time, but I do know that my change in velocity is going to be 10 times t, and my 80 meters is my change in position. So the height of this triangle is essentially going to be 10 times t, meaning I start with 0 velocity and my velocity changes by 10t, so my final velocity should be 10t. Using all of this, I should be able to finish solving. See here. Okay, so from the area of a triangle, why don't I do this? Why don't I keep this over here? Okay, I'll keep all the vertical stuff on the right hand side. So 1/2 times 10t times t has to equal 80. So that means 5t squared has to equal 80. Okay. Divide both sides by 5. Let's see what 80 divided by 5 is. So 80 divided by 5 is 16. Okay. And 16 has to equal, therefore, t squared. So t is going to be 4 seconds. So that's the time for this projectile to actually hit the ground. And if its velocity is 10 meters per second, and it's in the air for 4 seconds, then we can find out that it travels a distance of 10 meters per second, 4 seconds. We'll get a displacement of about 40 meters in the positive direction. So it's going to travel a distance of about 40 meters while it's in the air. Horizontal distance, I'm not talking about vertical distance. This is the horizontal distance traveled. And yeah, that's about all I could figure out for problems 1 through 4. Hope that helps you. I'm pretty sure I answered the question on the worksheet or came close to it. Yeah, have a good day and good luck.